Hey guys, Cam back here at the Battler workshop, and I must apologise. I haven't spent an awful lot of time on the slotting attachment over the last 1 to 2 weeks. It's been very busy at work, and 5 o'clock starts, and get home, and I just absolutely crash. And Danny's on his second week of school holidays, so with both myself and Rose working full time, we've had to we've spent some time with Danny after work. Right, today we're going to work on the shear pin assembly, and this shear pin goes between the crank and the ram. The idea being is that if I make a mistake, and who doesn't make mistakes, and I end up jamming the ram into the chuck, I don't want to break the saddle on the lathe or do any damage to the lathe whatsoever. I want to point on that mechanism that's going to break away for me and protect the rest of the components, and that's going to be a shear pin. Now look, shear pins have been around an awful long time. I remember many years ago when I was a young apprentice, one of the jobs we had in our workshop was making up shear pins and then burnishing them with a hardened steel roller to give a mirror finish on the actual shear point. Those days we had to off each bar stock that came in, we'd make up a tensile test sample, and that would go to the die shop, which we did have a very extensive die shop. We had 5 or 6 EDM machines, heat treat facilities. We had a metrology room. It was a very well set up die shop and tool shop. We'd pop it in the tensile testing machine, results off that, which would give us the yield on that particular bar stock. It would go up to the engineering department, and they would do their numbers and come back and let us know on that particular bar stock, when we machine the shear pins, what the shear diameter had to be. And yeah, it was a pretty boring job, and I think there was around about 60 to 70 shear pins on that particular cupping going into a main drive of a rolling mill. I do recall that the gearbox, the ball gear on that was around about 6 meters in diameter. That was a very big box. Twin input motors, massive motors, and then splitting out into a pinion stand into the roll sets in the mill. But that was there to protect those gearbox components. If the operator happened to stuff up when he's putting a slab through and took too much of a bite, you'd shear the pins off. And the worst case scenario on those was when you were a young fitter, was going down to try and remove half sheared pins. It was an absolute mongrel of a job, cutting those out to try and punch them out from either way. Alright, so back to smaller stuff. As I said, so we're going to make up our shear pin. It's got a 3mm diameter shear area. We're also going to make up a bush that's going to work in the crank, and we've got a couple of washers that we're going to make up as well. Just by way of example, that's the slotting head or slotting attachment I made up for my Bridgeport, and there's the shear pin assembly inside there. Now that's a 6mm diameter. I'm going to actually reduce that back to where it should be. In the crank arm here is where I have the bush, and she's a solid fit up inside the ram. It locks up inside the ram. So we haven't done any tensile testing. We're just going to take a punt on it. I have changed the design from what I originally had here. I was going to have a removable shear piece, but I thought, gosh, how many times am I going to shear the pin out for the amount of work this is going to do? So I've just made it nice and simple. I'm just going to go with a traditional style shear coupling arrangement. Alright, let's get set up in the lathe, and we'll make a start on him. Righty guys, got a bit of pardon me, 1.25 inch stock in here at the moment. It's pretty old stuff. She's yeah, she's pretty gnarled up with rust, this one. It's wasted away a fair bit, but yeah, that's like liquid gold to me, finding this sort of stuff down the scrappos. Alright, we'll get this knocked down to about 24mm in diameter, then we'll start putting a bit of shape into it. See that? Alright, it's a good fit. That gets locked off, so it's not going to be moving. Righto guys, I'm going to part this off to not quite the length, we're going to leave a little bit to clean up on. Then I'm going to swap it over and put it in my ER collets with my ER 32 or 32 to D14 adapter. I'm going to part this off as I said. One of the comments I got from an Ian Burtonshaw when I was doing the stainless steel feet parting off, he suggested that he uses get it in his frame there, WD-40 for parting off, and he does. He finds that really does the job. I use the CRC for my parting off, but I'm going to give the WD-40 a bit of a go. I've started off already, and it seems to be working quite well. So we'll just see how it pans out. Tell you what, ain't no complaints from me, mate. That did cut really nicely with that WD-40. Nice little tip. It's nice when you get those comments from viewers that have little ideas that you try out and you think, yep, that's a winner. Alright, as I said, we'll set this up in the ER32 collets and we'll start machining the crank end. Alright guys, we've got this set up in the ER32. I'm just going to face this off. Then take it out, give it a measure so I've got a datum that I can work to, and then I can machine that back to a length and then use that face as my datum face to get the shaft length. Alright, whip that out and measure it. Right, 0.04 to go. I'm just going to take that off with the emery. A nice smooth finish on that, because that's going to be the rotating surface on the crank. Alright, I'll do that now. Get that polished up and we'll come back when we're ready to start cutting this shear groove. Alright guys, I've shaped up the tool, so I've got a nice radius on that. I've trued the edge up against the AR 32 D14 chuck. I've touched off and zeroed, and we've got to go in exactly 10.5 to leave a 3mm diameter shear area on this. Alright, we're going to try the WD-40 and we'll see how we go with the high-speed steel, mate. Let's see if we can make this work. Well, there we go. Well, that's a throwaway. I'm going to keep going with that and just play around with it and see if I can get speeds, feeds, something that I might be doing wrong. And I'll make up a new one and come back to this stage and we'll see how we go. I'm also going to just side relieve this bloke off a little bit so that we're not rubbing down the sides as well. So I'll do that first. I'll have a play around with this, make up a new one, come back to this stage and we'll bring you back again. But yeah, we've certainly made a mess of that one. Now for what it's worth, I might be able to save this. I'm quite happy to side cut this a little bit further. I've reground the tip, I've actually ground in some relief on the sides and I've put a bigger chip breaker into it. So far so good. We'll see how we keep going, and then if we get to depth without absolutely wrecking everything, we'll side cut and clean that all up. When it did spin in the CR32 chuck, it did put a nice little burr on it, and that's why it was wobbling all over the place. So I've taken that burr off, cleaned it all up, and it's running really true now. So we'll keep going and see what happens. I've also increased the speeds a little bit on this as well, so whether that's going to make it more of a disaster when it grabs, we'll see how we go. Righto, we made it. Right, what I might do is I'm just going to set up the saddle. I'm just going to come in and just V that out very, very lightly, just a couple of degrees, until we get down to the bottom, just to make it look a little bit neater than what it is. Righto, that's come up really nice. We'll re-angle that and we'll cut the other side, and then we'll just clean up the OD lightly. Alright, we'll see how we go with this shot. So look, I've just set the pin in there. That's how it's come up. You can see where that, I don't know if you can pick that up, but that's where that burr was picked up, which was thrown off centre when machining it. So I've just cleaned that up and given that a rub with the stone. And what I was aiming for, as you can see here, those faces aren't touching. There's probably about a 0.2mm clearance there, which is exactly what I was after. And there's about a 0.2mm extension on that as well. So the idea is that I can tighten the screw and wash her up in this very tightly. This is going to remain free, so that there's no way it's going to bind up on the faces. And then we've got a Derrilin bush inside there, so the idea is that the pin will actually rub on the Derrilin bush that we make up in there. Got an oil hole there, so I'll pre-groove that so that the oil does get access into that bearing. I don't know if you can see it out here, but on this side here, I'm about 0.2 of a mil below the surface, so that when I put my socketed cap screw with my washer on there and nip that up, that is not going to, well, that's actually going to pull up really tight. It's not going to pull up against the face of the washer. It's going to lock that into that ram very tightly. So from where we were with that disaster, we've come up really well. The shear area there is just an absolute mirror finish on that, so I'm really happy with that. Alright, we'll make up the bushes and the washers now, and we'll try and get this assembled, and I'll give it a bit of a freehand run and see how that ram feels. Righty guys, just going to make up this little bush for the crank arm, 17mm OD. I've got a 14mm hole down that to fit the crank pin we've just made up, which is that little bloke just there. We managed to get out of jail on that one. I'm going to put a groove around the outside of that, which is going to line up with the oil hole, so that no matter where this is pushed into, it's going to be fed with oil. I want to make this just a very light press fit into that crank arm as well. All right, we'll make a start on this one. The material we're using for this again is the Delrin. We're about just a tad over 20mm on this, so I've got to take about 1.5 off to bring it down. Alright guys, just going to cut the oil groove into this. It's an external oil groove to allow the oil to run through it, and then I'm going to drill a series of holes around the periphery of that to feed into the crank pin. Just using our parting off tool that we used for creating our shear pin groove. Alright, that's quite nice. Alright, we'll part that off and we'll face it off the length, and then I'll pop a few holes around the periphery. Alright guys, just quickly show you what we've got before we put it all in and assemble it. So we've got our shear pin between the crank and the ram all made up. We've got a little Delrin bush, so I've popped a couple of holes in those. And we've got our two washers that we've just machined up to fit. So I'm just going to fit in this little bush. It'll be interesting to see how much crush I get on this. I might just push it in a little bit of the way. I'll just see how that's going to feel on it. Yeah. So what we may have to do is just take a little lick off the OD there. I'll get all this fitted up off camera. It's a bit awkward trying to work around the camera, but I'll get this all fitted up and we'll get everything moving freely and we'll see how it's looking. Oh no, so we've got that somewhat assembled up. I've got no tension on those gibs. Just put a bit of oil in there. bleeds a bit out of the top of it. Fix that. Just put a little daub in there already, but I'll just put a bit more in there. Righto, let's give it a crank. I might move it out a little bit, so I can't really get to it there. Right, so I'm just going to use an Allen key on the back here, and we'll see how that feels. Hello. Put it on the ball end. Some stuff out of the way a bit here. There. All right. Well, that feels fantastic. I'm really happy with that. That's a great result. Alright, got a little bit of shake in that crank arm, which is great, so I've got the clearance that I want. You can see the oil just oozing out a little bit from where I put it in there. As I said, I haven't got those gibs up tight, so that oil is going to come out a little bit. But for the first run, I'm very happy with that. Very happy. Alright guys, now what I might do next is I've got to make up the feet for this. And that's probably the last real component I've got to do. Inside the oil box or the gearbox here, I want to sandblast that and give that a coating inside. I've got my filler hole that I need to drill and tap into, and I've got this little hole here that I use to adjust the crank pin positions to change the stroke. I've just got to elongate that out about 1 millimetre. Alright guys, there's one thing I thought I'd better show you, and that's with it in its various positions. So we're up only about 3-4 mil shy at the top, just to show you the action. And that's very smooth and works really well. Alright, so I'll bring you back, we'll drop it right down and we'll do the same thing. Righto, so this is all the way down. We've gone about, I think it's about 42 millimetres is what we've come down. And this is on maximum stroke, by the way, too. This is stroking at around about 70 millimetres total length. And that is a very smooth action as well. So yeah, very happy with that. It doesn't take very much effort to move that. As I said, I haven't got the gibs done on this really tight. It's yeah, it's looking really good. All right, I'll leave it at that. We'll bring you back when we start to look at manufacturing these feet.